Hi friends, my name is Karthik Kumarke. I am doing my final year of MC in Veltech Multitech Engineering College. Now I am going to present a PPT of my final semester project. So to say with my title, my title is Information Hiding Mechanism to Prevent Data from Attackers. Now we will proceed on to the next slide. I did my project in DECRYPTED Technologies Private Limited, which is in Hindi. And my front end of my project is Java, followed by backend is SQL. Now we will proceed on to the next slide. My internal guide is Kulundan, who is working as assistant professor, and my external guide is Karthik Kumar, who is working as a project manager in Levixa Technologies. Actually, my main abstract of my project is information hiding data from sender to the receiver. Once sender sends a data, you have to solve a certain puzzle, and the packets which is sending will be split into many packets, followed by it should be sent to the receiver. Actually, once the receiver solves the respective puzzle, so that he can able to receive the data, or else he won't. In this kind of project, the main motto of this project is to avoid jamming attacks. In the existing system, jamming attacks considered to be one of the major issues. Whereas if we consider some conventional anti-jamming techniques, really extensively and spectrum communications provide bit level protection. Disadvantages: the continuous presence of unusually high interference levels make this type of attack easy to detect. Whereas in the proposed system, to overcome the jamming problems, we have created this project. We are using the two kind of mechanisms called classified and jam, and followed by the strategy of transmitted packets using protocol semantics or decoding packets on a fly. Advantages: relatively easy to actualize by exploiting knowledge of network protocols and cryptographic primitives extracted compromised nodes. There might be a cause of selective jamming, which leads to a denial of service attack where low effort on behalf of jammer. System configuration. To implement this project, we are using an IDE tool called Eclipse, followed by the operating system Windows, and the language supported here is Java. Use case diagrams. The sender has to send a data who has to solve the puzzle, followed by is encrypting the certain data, and it should be received by the receiver, and receiver have to decrypt the data using the concept of puzzle, so that the information is highly secured. If any interruption has been occurred during this process, it should be avoided. This is the architecture diagram of my project. The node A is called as the sender, and the puzzle should be solved, which is a form of encryption, followed by the jammer node. It should be avoided, blocks root request and reply, followed by it should be sent to the destination and decryption of the message, and it should be solved to get the data. Modules. To list out my modules in the project, the first one is real-time packet classification, followed by cryptographic puzzle hiding. Third one is hiding based on commitments. Fourth one selecting jamming module, and fifth one is hiding based on all or nothing transformations. Real-time packet classification. In this concept, we are using an ad hoc network, which is called a demand distance vector routing protocol, used to discover different kinds of paths which are available in the routes. A multi-hop wireless network, which consists of 5 nodes, is also used to implement the connection establishment. Packet transmission is completed in sender node. Cryptographic puzzle hiding. Here the puzzle hiding is used to hide the data which is made by the sender, followed by it should be used by the receiver. Sender generates a puzzle where puzzle denotes the puzzle generated function and the time required for the solution of the puzzle, which should be broadcasted. Hiding commitment scheme. A hiding commitment scheme which is based on a symmetric cryptography, which is nothing but a coding type. The main motivation is to satisfy the strong hiding property while keeping the computation and communication overhead. Selective jamming module. In this format, we are using only selective types of jamming module to be attacked. This implemented using multi-hop wireless network scenarios. First scenario, the attacker, which is targeted in a TCP connection established over a multi-hop, which is nothing but a mini connection. Hiding based on all or nothing transformations. Packets are pre-processed in AOMT before transmission but remain unencrypted. After solving a puzzle, the packet is visible to the user unless and until if it doesn't, it won't receive. The time lock puzzles. In the time lock puzzles, there should be a certain time limit which is set by the user of sender which sends a data. In that time limit, the user has to solve that puzzle, or else it will be elapsed and again you have to retransmit the data. Now we are going to see the screenshots. Here is the sender screenshot in which what are the fields he has to enter a data. In this screen we can able to see that puzzle question that user once selects a data, what is the puzzle he has to be answered. We'll go to next slide. Then browse the file to send. The user has to browse a respective file in the system location so that whatever the files he wish he can able to send. Here the files has been split into many parts for the purpose of encryption. Merging the packets. In the merging the packets, we are finally merge the packets which has been splitted by the sender so that receiver can able to see the correct data as possible. Conclusion. The problem of solving selective jamming attacks in wireless is addressed. The proposed schemes combine cryptographic primitives such as commitment schemes, cryptographic puzzles, and all other nothing transformations. Future enhancement. Future transmissions at various layers are predicted using estimated timing information, combined cryptographic primitives such as commitment schemes, cryptographic puzzles, and all or nothing transformations. Thank you. That's it, my presentation.